What's up, chemistry students? Today we got another video 3. This one's about calculating pH. Now, the first part is, what is the pH equation? So our pH equation is equal to negative log of our hydrogen ion concentration. Now, if, let's just say, we're in a situation where going the other way might be more effective, and we have the pH, however, we're trying to find the hydrogen ion concentration, we have to do the opposite of this negative log. Now, just like in math class when you guys are multiplying, the opposite of multiplying is to divide. With logarithms, it's actually set up that our hydrogen ion concentration is equal to 10 to the negative pH power. And so that's something that we should just kind of write down, keep in mind, because it does, in some situations, make our lives quite a bit easier, and we don't have to kind of dance around and work through a couple steps. This is just going to save us a little bit of time sometimes. So we'll go through our first situation, calculate the pH of a 0.00022 molar HCl solution. Now our first step is to always write out the dissociation. So we have HCl breaks down to be, HCl breaks down to be H plus Cl minus. And so our hydrogen ion concentration, remember our equation for it, is the number of hydrogens created multiplied by the molarity of that solution. And so when we look at it, the number of hydrogens created in this case is just one hydrogen, and we multiply it by our 0.00022 molar solution, giving us, you guessed it, 0.00022 molar H plus. And so now that's what we use in our pH equation. So we have pH is equal to negative log 0.00022 molar. And when we plug that into our calculator, we get a pH of 3.66. So we'll follow that same kind of basic steps and go through the next part, calculate the pH of a 0.00863 molar HNO3 solution. So we follow the same couple steps here, where we have HNO3 and we write out the dissociation equation. And so when we write it out, we have H plus NO3 minus. We double check, it is in fact balanced. And so now it just becomes calculating our hydrogen ion concentration. Now remember, it's the number of hydrogens multiplied by the molarity. And in this case, it's just 1 multiplied by 0.00863 molar, which gives us a hydrogen ion concentration of 0.00863 molar. And so now we go to our next step, which is just plugging it into our pH equation. So remember, pH is equal to negative log of our H plus concentration. And when we plug it in, that gives us negative log of 0.00863 molar. And our calculator pumps out the number 2.06. And so our last example here is a little bit more difficult, but it's not crazy difficult. It's just difficult in the sense that it adds a couple extra steps in. And so it's find the pH of a solution that contains 3.25 grams of H2SO4 dissolved in 2.75 liters of solution. And then our question is find the pOH. So our first step is to take this 3.25 grams of H2SO4 dissolved in our 2.75 liters and figure out the molarity that we have from this solution. And so our first step then is to find the molar mass of our H2SO4. Now I know we're all intelligent chemistry students and we already know how to do that, so we'll save some time and I'll just tell you guys it is 98.08 grams per mole. And so our first step then is to convert this 3.25 grams of H2SO4 into moles of H2SO4. So we set up our picket fence and we have 1 mole over 98.08 grams. And that gives us a number of 0.033 moles of our H2SO4. Now our next step is to take that number of moles and solve for the molarity. Now remember, molarity is equal to your moles over your liters of solution. So in this case, we have 0.033 moles of our H2SO4, and it tells us that it's dissolved in 2.75 liters of solution. And when we divide that out, we get 0.012 molar H2SO4. Now, using that molarity, we have to go on and figure out our hydrogen ion concentration. So we have to go back to writing out our dissociation equation. And so we have H2SO4. When it dissolves, it goes on to form, don't know why it keeps zooming me over there, it goes on to form 2 hydrogen ions plus 1 sulfate ion. And so that tells us, when we're trying to solve for hydrogen ion concentration, what is going on? Goodness! Our hydrogen ion concentration is equal to the number of hydrogens, in this case 2, multiplied by our molarity. Oop, not number 2. Number of hydrogen ions multiplied by molarity. So we have 2 times 0.012 molar, which gives us a hydrogen ion concentration of what? 0.024. Now, using that hydrogen ion concentration, we can go on and solve for the pH. Now, once we have the pH, going back and forth from the pH to the pOH is actually fairly simple. So we'll go through and we'll solve for the pH first and then go find the pOH. So remember, our pH is equal to negative log of our H plus, or our hydrogen ion concentration. So in this case, our pH is equal to negative log of 0.024 molar, which pumps out a pH of 1.62. Now, the next and final step is to solve for our pOH, what we're actually asked to solve for in our equation here, or in our question rather. And so the simple equation is that our pH plus our pOH always has to equal 14. And so we just take our pH that we solved for, the 1.62, and plug it in as our pH. So we have 1.62 plus pOH is equal to 14. And so to solve for pOH, we subtract 1.62 from both sides. So pOH is equal to 14 minus 1.62, which then gives us a pOH of 12.38. That's it for this one, guys. Go ahead, make sure you guys finish up the homework.